like to do in the next 20 minutes or so is to actually look at a number of examples. There's a very low-level one and there's a much more high-level one of, let's say, what our clients do with BIM. And obviously, because of the theme, it's subsurface. But before I do that, I think the interesting thing about BIM is that it's probably not a well-defined subject. So, at least for the sake of this presentation, can we please agree on that if we at Bentley look at BIM, we tend to look at it as a process, or to be more precise, a collection of processes that actually take care of the management of the asset all throughout the life cycle of the assets. What I like to always say, from design to demolish, because in the end of the day, you will have to tear it down and probably construct something new. I also always say it's nothing new. Okay, it may be new in the building industry. I'm not from the building industry. But if you look at other industries, and I think aviation is probably one of the best examples. If you buy a plane that actually flies for a pretty large period, and you have to maintain it, but you also have to be able to report on the status of the maintenance. This is obviously an industry which is heavily regulated. If a plane falls out of the sky, it's not a nice event. It's really, literally a matter of life and death. Automotive industry has been doing this. They don't call it BIM, they call it PLM, or if you want to be very nitpicking, PPLM, Product and Process Lifecycle Management. And clearly, a 3D model can be part of this. We think, if you look at it from a process point of view, it's important you have all the data, and there's no doubt and no debate on our side that a 3D model is going to be very beneficial. But if you look at it from a process point of view, a 3D model is not really mandatory. And the reason I'm specifically mentioning this is that I talk to our users on a daily basis, part of what I do. And I still see that 3D, certainly for old guys like me, is a bit of a challenge. So let's never forget that if you look at BIM as a process, it's important you have the data. And as I said, 3D will help, but it's definitely not mandatory. So as I said, the main part of this presentation is about two real-life examples. And I'll start with an easy one. It's not a very sexy picture, I know that, sorry about that, but it's real life. This is actually what clients of us use. It doesn't look fancy. What it is, I hope you all recognize the tree. And I never know that, but trees are actually set in concrete blocks. And that's the blue block. No, seriously, they seem to have a root system. I know nothing about trees, but I was informed by people who know that the root system is very big, and there is obviously a relation to the tree, the size of the tree above ground, to the root system subsurface. And it's not very handy if you plan a new piece of sewer and it actually crosses the root system of a bridge, of a tree. As I said, I know nothing about trees. So what you see here is actually a very tiny part of a 3D model of the sewer systems of the city of Eindhoven. And obviously what is done here, I think it shows a red, the red sewer pipe is actually a new pipe. And by incorporating it with surface information, you could actually see that this is probably not a wise way of routing it, because it will actually have to go through the root system of the tree. Very simple example, The interesting part of it, it actually got a lot of positive response from the users in the city of Eindhoven. Hey, we are a graphical company, nice pictures. This is not a nice picture. It's almost an ugly picture, but it did a lot of good to the people who are actually managing the sewer system. And the other interesting part is this was created using existing information. Because let's not forget, certainly in a country like the Netherlands, there's an enormous amount of information already available, right? And if you look at this particular case of the sewer system, there were digital 2D drawings, models, whatever you like to call it, where the sewer system was totally pictured, but obviously only in X and Y. And there are administrative systems which contain all the, let's say, information about the components of the sewer system. So you have the Z value, you have the diameter, the material, all that kind of information is there. And I think the beauty behind all of this, a much more knowledgeable colleague of mine was actually able to do a little bit of scripting, combine all that information, and generated that 3D model. And as I said, it's not a sexy picture, no, but it's a very functional model, if you like. And one of the interesting things, when we showed it to the people who maintain the sewer system at the city of Eindhoven, there was actually one gentleman, he said, hey, that's interesting. That piece of sewer is actually physically on a different slope than everybody thought. So instead, I don't know how it was, but instead of being like that, it was like that. And he at that very moment said, I now understand why we always have problems here. We never had expected that, because we expected that piece of sewer to slope into the other direction. And it's a pretty simple example. The beauty is that these guys were not into 3D, not into IT systems, but this created actually a lot of value to them in everyday practice. And this is not just a simple picture. There are links to the administrative data as well, right? So you actually can select one of the pipes and bring up all the administrative information out of different systems, which is already there, right? So it was sort of interesting because you look at the picture and it looks very simple. It was created by reusing data, and it immediately serves the purpose to the people who, on a day-to-day basis, have to manage the sewer system. Okay, that's one example. As I said, pretty simple, nothing sexy, but very functional. The next one, and I couldn't avoid it, I know that whenever you see somebody from Bentley speak, he or she normally mentions Crossrail. Well, I didn't want to not do it. There's a certain expectation level here. But hey, Crossrail, that's underground, right? This is a significant piece of railway under the city of London. And this is totally BIM. It's subsurface. It's a lot more sexy than just the sewer system in the city of Eindhoven, and this is no disrespect to the city of Eindhoven. The interesting part is, being in the UK, I think it's clear, at least that's my guess to the audience here, that the UK government has put down quite a number of demands about BIM, right? They have real requirements there, and if you want to do anything for the government, it's pretty simple. You have to comply to those requirements. It's also interesting, the CEO of Crossrail, because Crossrail really is a project. Once they are ready, the organization itself shall stop to exist, and they transfer all the data to, I think it's Transportation of London actually. In the meantime, they have started Crossrail 2, so it's not, it will continue. But clearly, in the end of the day, all they have created, all the designs, the models, all the data, will be handed over to the organization who is actually going to exploit that railway, who is responsible for maintaining it for the next 100 years or so. And the interesting statement, which is actually made by the CEO of Crossrail, is that his team is building 2 railways. There's obviously the real one, but there's also the virtual one. And the virtual one, you just saw a little piece of that virtual railway. And what is important, and it is, I think, extremely important to emphasize that, those 2 have to be in sync. If you want to use that 3D model with all the data connected, because clearly I only showed the picture, but there is a lot more to that picture than even 1,000 words can say. They have to be in sync, because the vision is that once all of that is ready, the 3D model is actually an excellent point of entry to go in, and let's say you have to plan certain work at a certain location, hey, that's geo, isn't it? If you have to do that at a certain location of the railway, the way they vision this is that the maintenance people will obviously use the 3D model to select the part of the tunnel system where they have to do work. Because of the intelligence, they will get links to all the data, drawings, models, whatever you have, which are relevant to that particular piece of the tunnel, and they can obviously use that for planning and doing whatever maintenance work they have to do. So basically, in the end of the day, it's now obviously used in the design phase, and there's lots of things, and I think that's very obvious to the audience present here, that you can do in the design phase with a 3D model. But there's also a lot you can do once this design has become reality and it all moves into the maintenance phase. And let's not forget, if you look at a piece of infrastructure, I mean, I was born a long time ago in the city of Rotterdam, and we have a tunnel there, the Maas Tunnel. It was completed in 1938, almost 80 years ago, right? It's still there, it's still used. So the maintenance period of your average piece of infrastructure is pretty long, right? And there's a lot of money, obviously, going around in the maintenance phase. And it's almost a no-brainer, but if you have a 3D model and if you detail it well, you can do very nice visualizations. And you can use it for all kinds of purposes. You can do it for emulation, you can do training, you can instruct your train drivers. Well, bad example, a lot of the metro trains actually don't have drivers. But if they had, you could instruct your train drivers long before it's out there in real life. So that's a much more complex example. Both examples are not somewhere in the future, they are actually here, now, and are in use, right? So, let's try to get to some conclusions. That's always dangerous, but hey, what's life without risks? I would say BIM is everywhere, right? And whether you like to call it BIM or PLM or what have you, so it's also underground. And I'm tempted to say, hey, it's nothing special, it's nothing new. If I look at what our clients have been doing for the last, I don't know, 10 years or so, they all have been doing BIM. Okay, probably not the whole BIM, if you like, but they have been doing bits and pieces of what we now call BIM. And because, well, if we do something infrastructure, it's usually located on the earth. There is a location aspect to all of it. GIS is sort of integrated. You cannot build a bridge if you don't know where that bridge is. You cannot design that bridge if you don't know how the terrain looks, how the river looks, and all that kind of important information about the location. So I don't know if I disappoint you heavily, but I would say a lot of it is already done and keeps continue to expand, and it's getting better and more fancy and what have you, but it's already there. It's clear that there's a lot of data there, and if you do a little bit of effort, you can actually reuse it, which is good. Reusing data is obviously positive, yeah, a 3D realistic model is obviously worthwhile. And I like to end this presentation with a few examples of actually photorealistic 3D data, which the technology now makes it pretty easy for you to capture. So, anybody want to guess what you are looking at? Ah, you hadn't counted on that, eh? Interaction. This is actually part of the sewers underneath Paris. I think it's well known that underneath Paris there are massive sewers. They are brick. They have been there for a long time, and clearly they need to be maintained and they need to be inspected, right? Because in order to maintain them, you need to understand where you have your problems. You need to have an idea of what the damage is, and then you can obviously plan your maintenance work. So the top one is a picture of it, and the bottom one is actually a 3D model generated out of that picture. If you want to contact me, my contact details are there. Thank you very much for your attention.